Hello class. In this video I'll continue with arithmetic operations in C++. The next operation I want to look at is the modular operation, which is denoted by percent symbol. Modular operation produces the remainder of the division. So in this example, what you see here, 9 mod 4, the answer is 1, because when you divide 9 by 4, the remainder of that division is 1. So 4 goes into 9 twice. That's 4 times 2 is 8, and then 8 subtracted from 9 will give you 1, which is the remainder. So the modular operation is the remainder of the division that you have. So 9 mod 4 gives you 1. But also keep in mind that if the first number is smaller than the second number, 9 mod 4, in a way you're saying what is the remainder of 9 divided by 10. Since 10 is larger, the modular operator will return 9. So let's look at this. So here it is, C out. I'm going to let's say have 17 mod 3. So 17 divided by 3 goes into 17 5 times, that's 15. It should give us 2. Right? 15 minus 17 is 2. And then let's also try another one. What if I do 3 mod 17? 3 is smaller than 17, right? And let's look at that result as well. End line. Semicolon. So line 17 basically outputs the value of 17 mod 3 and also 3 mod 17. And when we run this, for the first expression we would expect the answer to be 2. For the second one the answer is 3. So running this will give us 2 and 3. It is correct. So that takes care of modular operators. There are a couple of examples in the textbook that actually shows application of modular operations, which you need to look at. Now, augmented operators. In C++, you also have augmented operators. They are useful, and many C++ programmers use the augmented operators. They are very common. Let's say I have, let's say I'm going to reassign a value to x. I'm going to say x is equal to, let's say, 10. X is declared earlier in my program right here. X is declared as an integer, so the program is aware of existence of this variable x. It was assigned 5, but now I'm assigning 10 to it. Right? When I say or use the augmented operator such as this one, x plus equal to let's say 20, when I do this, that basically means the following line of code. It will take x and assign to it the same value of x plus 20. So it basically adds 20 to x. Right? If I see out the value of x right now, x is equal to x. Oh wow, I missed 2 less than symbols here. There you go. If I run this, we should see x is equal to 30, right? Because it will add 20 to existing value of x. So we'll run this. X is equal to 30. That's correct. And this is called augmented operation. So the value of x is right now 30. So I can say x minus equal to, let's say, 5. Right? What does that mean? That basically means that we have x, the new value of x will be equal to the old value of x, but subtract from it 5. That's what it means. Right? We can copy and paste this line of code, Control C, and then Control V, and I'm gonna look at the value of x again, and here it is. I subtracted 5 from 30, and that is 25. And this works out with other operators as well. I can have, now the value of x is 25, correct? I can say x divide equal 5. That means that divide x by 5 and store the value back in x. That basically means the following: x now is equal to x divided by 5, integer division, right? And then the same control V, the same output line. We'll take a look at this, which is 5. 25 divided by 5, the new value of x is 5. So these are augmented operations. And then the last thing we want to cover is the increment and decrement operation, and that is also very simple. You put comments here. Let me start with y and assign to it value 10. So y right now is 10, and let me push this down so that it is more clear. So y has value of 10. When I say y plus plus, that means that I have incremented y by 1. So that means y is equal to now the old value of y plus 1. So the value of y right now is 11. See out, y is equal to y end line. Again, and too fast. So we'll look at the output. So this is incrementation. So it was 10. Now y plus plus increments the old value of y by 1. So now the content of y is 11. Similarly, decrementing a value would be y. By the way, let me just show you that this is called post increment, right? Post increment, because plus plus show up after the variable. Here is pre-increment, right? But what you notice, this post and pre-increment, it does pretty much the same thing. It increments y by another value. So the value was 11. Now this pre-increment adds another 1 to y, and the new value of y is now 12. It's 12. Now this is pre-increment and post-increment. That's pre-increment because, again, the plus plus shows up before the variable. The same thing holds for negative. You would have this is post decrement, so it reduces the value of y by 1. Control V. And then we have pre-decrement. It reduces the value of y by 1. So I have basically reduced the value of y twice, each time by 1. So the value of y right now should be 10 because it was 12. So if I run this, I should see the value of y being equal to 10 again, back to 10. There's 10. Right? Pre-incrementing, post-incrementing, or pre-incrementing, post-decrementing. Now, this post-increment and pre-increment, they are exactly the same if the statement that you have, if the command that you have is only made up of that single incrementation. For example, y plus plus or plus plus y. But if I use this increment and decrement in an expression such as the following that you would see. Let's say I'm going to assign to x the value of 15. I have x is equal to 15, right? In fact, let me just declare another variable here. Here's another integer z. Right? Now I'm going to say z is equal to 2 times y plus plus. Right? Now if I use this statement here, what happens here, this is post increment. That means the old value of y is used in this multiplication, right? That means that the value of z will be equal to 2 multiplied by the old value of y. The old value of y was 10 so far. So z will be equal to 20. Once the old value of y is used in that expression, then y is incremented. After this, y will be equal to 11. So it is post incrementation. You use the current value of y in the expression. Once the expression is computed, you increment y. So we can actually take a look at z here. C out. Just bring this up a little bit. C out. Z is equal to z, and let's look at the value of y as well, and then y is equal to y, end line. We run this. Remember, z should be 20. At this stage, keep in mind, at this stage y is equal to 10. We checked it. We know that y is equal to 10. So z is equal to, will be equal to 20, and then y will be incremented. We'll run this. And z is equal to 20, y is equal to 11. Great, as expected. That was post incrementation. Now, let's do it a little bit differently. Let's again assign y equal to 10, set y back to the original value, and let's say z is equal to now 2 times now pre-increment y. Right? Let's do it this way now. Now in this case, what happens? You first increment y. Y will be equal to 11. You first increment it, right? And then use it in the expression. And then z will be equal to what? Z will be equal to 2 times 11, which is equal to 22. Very different. So when you use pre-increment, post-increment, similarly pre-decrement, post-decrement, in an expression, you have to watch out how the expression is going to come out. So in this particular case, let's take a look at the output here. Control C, Control V, and then we'll run this. And let me just look at it. What do we expect? We expect y11 and z22. All right, let's go. y11 and z is 22. Right? So in both cases, y will be incremented, but the question is, when is y incremented and which value of y? The old value of y or the new value of y, the incremented value of y, is used in the expression to figure out z. That's the key.